Hey everyone, and welcome to this explainer. We rely on our senses absolutely every single day, but there's one we kind of constantly take for granted. Well, until we lose the others anyway. Today, we're uncovering the hidden cognitive machinery behind auditory observation. We usually treat hearing as this passive background process, but it's actually an incredibly dynamic system. Your brain is constantly treating your ears like super detectives, gathering unseen clues from the environment to actively construct the reality you experience.
So what actually happens when we close our eyes? Imagine walking through a pitch-black room. Your brain doesn't just, power down because the visual data is suddenly cut off. No way. Instead, a highly sophisticated biological backup system kicks in. It begins mapping your surroundings, calculating distances, and identifying things based purely on the way sound waves bounce and travel through the space around you. It's like a giant invisible puzzle.
Okay, let's dive into this. While visual processing usually dominates our conscious attention, our eyes give us a highly detailed picture of what's right in front of us, and they usually get all the credit, our auditory system is running a relentless 360-degree background radar. Our eyes give us the obvious, sure, but our ears decode the unseen environment. While your vision is super focused on a single screen or task, your ears are constantly pinging the wider world, processing spatial relationships and potential interruptions without you even realizing it.
Let's strip away the visuals for a second and play a quick game to see how rapid this cognitive processing really is. Imagine sitting in a totally silent room. Suddenly, the air vibrates with a sharp, synthetic frequency. Ring, ring, ring. In a fraction of a millisecond, literally before you even consciously register the noise, your auditory cortex is already cross-referencing that specific frequency against a massive internal library of known acoustic signatures.
So what object makes that noise? You immediately recognize it as a telephone, right? But think about the mechanics of that realization for a sec. You didn't need a glowing screen, you didn't need a plastic casing or a label to identify it. Your brain instantly decoded an invisible acoustic signature and translated it into a physical object. It even went a step further, seamlessly triggering a motor response, that sudden, almost involuntary urge to reach out and answer it, all entirely based on a sound wave.
Let's keep it moving. Now consider a biological acoustic signal. Woof, woof. Your brain doesn't just stop at the basic categorization of, oh, that's an animal. Nope. It instantly analyzes the pitch, the timbre, and the reverberation of that sound. From a single woof, your brain paints a complex spatial and physical picture. It's estimating the dog's size, how close it is, and even its potential threat level. Your mind is seamlessly filling in the visual gaps, constructing a complete mental image purely from fluctuations in air pressure. Or take one last clue, the rhythmic pitter-patter, splash of rain hitting a window pane. Before you even pull back the curtains to confirm it visually, your auditory system has already analyzed the environment and dictated a predictive behavioral change. You instinctively know to grab an umbrella or a raincoat before stepping outside. This is a perfect demonstration of seamless, predictive decoding happening entirely in the background, keeping you prepared for an environment you can't even see.
Now, what's really interesting about this slide is how it defines what we've been doing, auditory observation. These everyday instances are perfect examples of it. It's the profound shift from hearing as just a passive bodily function to an active, inquisitive skill. It's the conscious deployment of our ears to gather essential data when visual stimuli are absent, obscured, or just unreliable. Auditory observation means actively interrogating your environment with your ears, treating sound not just as background noise, but as a rich, dense stream of critical information. And this brings us to the broader architecture of sensory perception. It's absolutely vital to realize that sound waves themselves aren't reality. Actually, scratch that. They are just fluctuating patterns of air pressure. Reality is what your brain constructs from those waves. Your auditory system takes these isolated, fundamentally meaningless vibrations and weaves them into a coherent, navigable understanding of the world. It's an ongoing, real-time translation of physics into human experience. Think about the sheer volume of environmental sound clues our detective ears gather every single day. Our environment is a constant, overlapping broadcast of data. We process biological signals like a bird chirping or a cat meowing to understand the ecosystem and behavioral states around us. We simultaneously process mechanical warnings like a car honking and structural signals like a school bell ringing. Our brains instantly map these diverse frequencies to highly specific social contexts, timeframes, and urgency levels. And it does all this without requiring a single second of conscious thought. If we look under the hood at the cognitive mechanics, it happens in a distinct, rapid sequence. First is the physical capture of the environmental signal by the ear. Next comes the rapid decoding of that clue by the auditory cortex, referencing memory and pattern recognition. Third is the integration of that clue into our overarching sensory perception. And finally, and this is the big one, this data shapes our broader cognition and communication. Active listening literally dictates how we navigate, understand, and interact with our reality on a moment-by-moment basis.
So the crucial point is the dividing line here, which is intent. Think of passive hearing as an open microphone, just letting ambient noise like the low constant hum of a refrigerator wash over you without any real analysis. Auditory observation, on the other hand, is turning that microphone into a highly directional spotlight. It's consciously scanning the environment for vital, actionable data, separating the signal from the noise to keep you informed and safe.
Ultimately, to quote the source material directly, our brains take all these sounds and try to figure out what they mean. It is a continuous, exhausting, and profound computational effort happening entirely behind the scenes. Your mind is endlessly sorting, filtering, and assigning meaning to the chaos of vibrations around you. Without this constant background decoding, we would be completely isolated from the vibrant reality humming around us.
So here's the thought to leave you with. The next time you find yourself in a visually unstimulating environment, try closing your eyes. Activate that auditory spotlight. Let your brain do the heavy computational lifting it evolved to do. Take a moment to genuinely ask yourself, what vital clues might you be missing right now simply by not listening closely enough?